now. So sorry about all that. The computer here did not work at all. Still isn't. So not much we can do about that. So unfortunately, that means my example Gantt chart here isn't going to work. So we can do some chalkboard work if we've got a little bit of time. So we'll jump right in. When I was driving back from Cincinnati with my wife yesterday, she had me read this to her. She was curious what I had planned. And she said, that's really boring. You got to put in like some kind of YouTube video or story at the beginning. So I scoured the internet for an interesting project management video, and I found one, and now we probably don't have time to do it. So I should probably skip by this. But just for a teaser, it's based on Disney's Sword in the Stone, so it has to be good. We'll go right into learning objectives. So what you're here to learn today. A few things. So this is different than project management lectures we've had before. So first thing, understand why project management, because some of you may think that's a waste of time to spend time figuring out how to spend your time when you could be working. I promise it's not. Understand how to scope a project. So scoping a project properly is one of the most important things you can do to ensure that the project is done successfully. In fact, my boss at my previous job said that scope creep was the #1 issue. So scope creep is basically change in scope. The #1 issue in stopping projects from being successful in industry. You're going to know how to create and maintain a Gantt chart. I know that sounds like a lot of fun, but they're useful. And then I assume most of you are doing EPICS in your labs, at least these first couple of weeks. Haven't heard of that? Well, you'll hear of it now. And I'll show you how to get a little bit more value out of that than the way I've seen some of them done. So for reference as to where we're at, project planning, that's this lecture. So I see everything from a design document perspective, because in the industrial world, all of your designs, when you report them up to your management or your customer, you're going through design documents, okay? So first stage of that, project planning. This is closely all replicated in the design document that EPICS has. That's today. Design inputs we'll talk about in 2 lectures on the 15th and on the 22nd. And then we'll talk about in design inputs, we'll talk about 2 things, really. User needs, so that is what does your user want out of your product, and then specifications, and that is, as an engineer or someone who's working with engineers, how do you get a functional product out of those user needs, okay? So my user need could be something like, I want a kite to fly, and as an engineer, you're going to figure out how to make it fly, okay, and that's your specifications. Then we'll talk about design outputs. That is everything we talk about when we say, here's the plans on how to build something. Okay, so your really goal as an engineer is to get the plans on how to build something, not to build it. We build them here because we're more fun than real engineering jobs, but that's the plans on how you need to do it. So the prints, schematics, the bills of material, everything you might need there. Then on the 29th, that's the week right before midterm design reviews. For those of you who keep coming along with me, we'll talk a little bit about effective design reviews. So how to present the information that you have, show an understanding of the design process and how you got to where you are. So I think we can improve that a lot. And then design verification and validation. These are 2 important concepts in testing a device. Then we'll talk about design transfer. So most of you in EPICS won't see design transfer. That is the activity of going from the design like you guys do, where you build specifications, to putting it into a production environment. So if any of you commercialize your projects here, I know there's a couple that are in that kind of pipeline. Then you may go through design transfer, and that's something that I can help you with. If you need help, come talk to me. And then the last stage is design changes. So you could say the last change is design retirement, but there's not much to that. But design changes. So you've delivered a project to your project partner here, or you've gone into an industry job after this, and you've put a product into the market that people have bought. You need to change something. So you found an early failure. There's something you need to change. You're iterating the product. How do you control those changes in a way that you can understand them, rationalize to someone who takes over for you later why you did what you did, things like that. That one we're also not really covering in a lecture this semester. If you're interested in the topic, get a hold of me. For those of you who don't know me, I think most of you do, I am your lab manager for EPICS. My office is right upstairs. You'll see me around if you stay in EPICS very long, so please do. So why project management? So project managers, their real job is to set the path for success for a product, okay, or project. So your project team has lots of smart engineers on it who are good at making things, but they're really bad at staying focused in a deliberate path toward delivering something useful to people, okay? if you are a project manager, or if you're not a project manager, but you're someone who's working with one, so someone who's project managing you, understanding their role and why they're doing it is really critical. So when we get into small projects, like tinker projects, you guys can make really incredible things. I've seen it over and over just by tinkering, playing with something until you arrive with something cool. But you can't put a shuttle in the space or build an F-150 or an Apple computer, anything like that, by tinkering. Okay, you've got a plan, you've got to have a strategic set of goals, how you're going to get there and execute them. So that's the job of a project manager. It may seem like it's spending a lot of time planning out other people's time or your own time, but it really does increase the likelihood of success, and it's going to reduce the time to deliver the project overall, because you're going to be working together in a concerted effort. So you're not going to be a team of 10 people paddling at random times, you're going to be paddling together. Okay. The other big job is making efficient use of resources. So that's both money, time, equipment, anything you might have. That's the project manager's role. For you guys, it's mostly time, a little bit money. I know we kind of delegate that to the CFO. But you're really looking at how do you stack up your team members so that everybody's sharing the load, working together. So that's why project management in the dry sense, that fun little video would have given it to you in the fun sense, sorry. One point to remember, as a project manager, you're the project manager, you're not the boss. So you don't make all the design decisions. That's usually the engineers or design leads on your team, okay? And as you get into your future jobs, it'll be the same way. So remember, it's not your place to tell someone you can't design it like that. Your job is to help move the team together in concert, okay? If you're a design lead, that's your job. You should yell at people if they stray. So product scope. So I talked a little bit in the beginning about product scope being one of the most important things in defining a project and doing it well. So when you set the scope of a project, you're setting the bounds. You're saying what is included and what's not included in this product, okay? So it's really critical, because as you go through a product, people will make suggestions, try and change things. So example of product scope, a bad example. So I'm going to go through with this smartwatch example in a few cases. So everybody get a general sense of what a smartwatch is. It's a watch that does something more than just tell time, right? So a bad example might be, I'm going to make a smartwatch that displays time, and it also communicates with another device to do some other functions. Okay, like it's going to do some cool other stuff. Right? That's a really bad product scope, because what is included in those other functions, right? What kind of devices do we have to make it work with? So you really need to try and specify it down. So a better example would be to say the smartwatch that we're building is going to be a wrist-worn device. So it's not a pocket watch, it's not a Google Glass or something like that. It displays the time constantly, so you don't have to turn it on every time you want to check and see what time it is, right? It can communicate with, say, Android and an iPhone, right? You may be more specific. If you want to be better, say it's going to use an iPhone 5S, and it's going to use version something of iOS software. So the more specific you can make it, the better it will be. So going on more, say, it's going to use Bluetooth specifically, so we're not looking at multiple forms. You might not know this up front in your project. You may want to leave it open deliberately to say we're going to use wireless communication, but not specify what, because you don't know what the best is. But the more specific, and as you go through your project, if you can try and make it more specific, it'll be better. So let's just take a few minutes. Well, let me get through scope creep first. So scope creep is uncontrolled changes in your scope. So controlled changes are okay. So we're saying as a group, we agree that we need to include these features as you become more specific. So you started with wireless and you went to Bluetooth, right? Maybe you went to a specific standard of Bluetooth. Scope creep is when you have somebody say, that smartwatch is cool, but I really wish that it would show me all my text messages too. Well, I just added in a lot of complexity now, right? Because before you were telling me about weather and music playing, now I've got to get text messages on. How do I push those over? Things like that. Maybe when you get in industry, you get salespeople are always telling you, no one's going to buy this thing if. No one, every industry you'll hear this. No one will buy this smartwatch if it doesn't take pictures. It's got to have a camera. Like, it's got to. Everybody wants to take pictures with their phone or their watch. Nobody wants to take pictures with their watch. Don't kid yourself. But these are the things that build scope creep, right? So there's another interesting YouTube video out there I saw talking about the Bradley tank. Supposedly started out as this light reconnaissance vehicle, and then as all these bureaucrat generals sat in a room, they said, yeah, but it needs to have a turret on top and a cannon, and it kept building up, and now it's like the biggest tank they have. Right? So So, you know, comic examples, but this happens all the time in your projects. I know I've seen it in EPICS projects where the feature set keeps building up, and then you never build the core set. Where really the critical thing, especially for new projects, we'll skip this one for time. Goal for new projects. So this is something that's not an iteration of something that's on the market. The goal's got to be the minimum viable product. And you should always have that phrase in your head when you're working with your teams, minimum viable product. So this is, what can I deliver to my project partner that I can practically build that will work and serve their basic needs? So deliver the minimum viable product, and then let them come back to you and say, I like this thing, but it needs this feature or that feature, and get to the things that are really at the heart of the matter. Because if you stop and ask someone just to give you their dream space, which is what every customer does, they'll tell you everything they can possibly think of that it should do, right? You'll never build it. You'll never get there. So you need to limit it down, and if they have the actual thing and they're using it, it really helps them avoid being distracted by all the possibilities and think about what they really want and need. So especially for new products, which most of yours are, all of them probably, you're in that phase. Unless you're in the redesign phase in EPICS, we don't iterate products a lot, right? So if you're working for Ford today, and you're building the 2016 Ford Taurus, I don't know if that even exists anymore, but if you're building that, you want to build a rich feature set, because you've been building this car for years, and you've been iterating and building up the feature set, right? But if you're building something that's brand new, right, you're building the first ship that's going to take passengers to space, you don't want to worry about how big the first class compartment's going to be. You want it to take off and land. So focus on the minimum feature set. So let's do a little bit of a project scope activity. So all of you are on a team on a project right now. So partner up with someone who's not on your project. We'll just take about 2 minutes and formalize a statement for your project, what it is. Okay, so be as specific as you can. And then after 2 minutes, we'll trade with your partner and give each other some feedback on how could you be more specific, how could you drill it down so that you narrow yourself in more on what your project should be. So, go. All right, if you haven't yet, trade off. So if you've written your statement, trade off. Just about 2 more minutes. Okay. All right, everybody. Did you get a good chance to look at each other's documents and see your statements? Hey, did everybody get a chance to look at each other's statements and see how you could try and be more specific about what your project scope is, try to be more specific about how your project is formulated so that you can, as you go through your project, you as a project manager or as a team member can fight that scope creep. I hope you got something out of that. I'm sorry for having to rush through this a little bit. Didn't expect to lose 15 minutes of the lecture. So going to project planning tools, there are a lot of project planning tools out there. Project managers use all kinds of different things. If you go into industrial engineering, you'll learn 100 of these. So some common things, calendars, PERT charts. The two that we really use are EPICS and Gantt Charts. So EPICS are probably not a traditional project planning tool, but we use them here, so I'm going to talk about them. So Gantt Charts, they show a project schedule, so they show the tasks that you need to do to complete a project with dependencies. So you're going to say project A, or task A will start. When it finishes, task B can start and then go. Or those dependencies can change. We'll talk about that a little bit. Had a nice example built for you, but the computer not functioning, I can't pull it up. So it'll show you which tasks can be done in parallel versus which ones have to be done in series. So series means that one task has to fully complete before the next one happens. When tasks are done in parallel, that means you're doing multiple things at the same time, okay? So that's a common concept, but it becomes really important in project management when you start to look at how do I compress my timeline and get my project done faster. The more things you can put in parallel, the better off you'll be. But there are oftentimes you want to put gates on things, so you do them in series so that you don't jump the gun and have to redo work. And again, much like with your project scope, your detail should increase as the project progresses. So in the beginning, your Gantt chart might be really basic, include just the general goals that every project has. But when you're getting close to completion, your Gantt chart should be down to item level detail where you're looking at, Hadley needs to do this specific task for us to get this done, and it would be at that individual level. So detail should increase. This is what a Gantt chart looks like if done properly. So you can see there are tasks that are stacked on top of each other. Those tasks are being done in parallel. Tasks which are stacked left to right are in sequence. And I don't really have the detail here. I was going to open this up for you, but usually you can lay these out in project management software, something like Microsoft Project. I did this one in Project Libre, which is an open source example of the same thing. It was pretty much a Microsoft Project copy, but it's open source. And you can build these timelines out in detail, and it will give you an indication of what the critical path is. So critical path is the task that if that task slips a day, the whole project slips a day. Okay, so that's the shortest timeline route down the path. So I'll kind of give you a Blackboard example. I'm sorry this isn't the best way to do this, but I built out a really simple outline here. So usually you'll put in the phase of your project, so project initiation, design input, design output, all the phases that you have. There's more than this, but this is what I could fit here. Make it big enough so you could read it. And then you indent each of your main tasks inside of each of those. And then when you build your project dependencies, you'll say design inputs can't start until project initiation is done. So then you don't have to, as you build this, manually set dependence of each of these tasks on the tasks up here. It'll have the whole phase dependent, okay? Because you don't want to do your design, say your design output phase should never be parallel with your design input phase, because you would have no idea what design outputs you're building until the inputs are specified. In regulated industries, in general, the government won't let you do this. So I come from medical device industry. If you built the print of a part and that was dated before you had done your design input phase where you said your specifications, they won't let you sell that product anymore, okay? So it's very important. So a Gantt chart is a bar chart, and the length of the bar indicates the amount of time the project is going to take. So on the x-axis we have time, on the y-axis you have all of your projects. So I'm going to say starting at time 0, I'm going to start working on my project charter. I'm going to build a box for that, okay? And it's going to take this much time. I hope you can see this a little bit. So your project initiation phase basically takes this long. Now I'm going to go into my design input phase. I'm going to interview my project partner, and I don't want to start that until I've got my project charter done so I know who my project partner is. I'm going to say that's going to take this long. And then I'm going to build user need doc. So I'm going to, after I've met with them, I'm going to talk about what are my user needs. And I can't start that until this is done. So I'm going to build a box here for that. And then I'm going to look at build my specification doc. Now, your specifications, like I said, are an engineering way of specifying how you're going to achieve your user needs. So you can start those before your user needs are done, because maybe you have 100 user needs and you've started building specifications for the first 50, but not all of them. So those two need to finish up at the same time. Okay? So I might say build my spec doc is going to take a shorter amount of time, but it's going to end at the same time. Okay? So these are ending simultaneously. And as you go into something like Microsoft Project, we're going to have a skill session. I'm not sure when the date of that is yet. I think it's been posted on Microsoft Project, so you can walk through the nuts and bolts how to do this. I wanted to walk you through it today, but technical difficulties had another idea. So I've said my project initiation phase takes this long. It's these tasks. My design input phase starts when that completes, and it ends here. Okay? So that's how I can set, here's a project phase, here's the tasks I need to do. And as you build this in more detail, this is obviously a very high-level example, then you can start to specify what's series and what's parallel, what has to start to finish and what has to finish to start, things like that. You can go on and do this again. So I'm going to start developing schematics. That's going to take a really long time, but I'm not going to start that until I've got my specifications done. Okay? So this is the basic form. So that's the design output phase. So you should have dozens of tasks in most of these when you get into the end levels of a project, and you have that done. But that gives you a basic feel for the form. So that's how this chart was built, but done in software. So it makes it a lot easier that way. Does anyone have any questions on that basic format? It's pretty simple once you start to do it. It's not simple to show on a chalkboard, sorry. So any specific questions before we move on? No? One? No? Okay. Did everybody bring their project timeline from their project? Anybody? Somebody? 3 of them? Yeah, 4? Okay. We had a 5-minute task here to do this. I guess if everyone doesn't have them, maybe the best thing to do is for your homework for this week, before next Monday, please send me your Gantt chart for your project. I will give it a quick review and give you a few notes on how to improve it, okay? Some of the things that you should look for in your own chart are, is it in sufficient detail for your project phase? So if you're starting your project, you're at project initiation phase, it'll be really basic. And I can send out a PDF of my example. It has really basically all of the base functions that every project should have at startup. And it will look a lot more complex than you think it should for a startup, because these should become pretty lengthy as you go through. Another thing to look at, each of your tasks, as you get into those end phases, they should be actionable. By actionable, I'm going to talk about this more in PIGS. A goal that is actionable should have concrete evidence that it has been done. Okay? So when you get to the end level of your Gantt chart as your project is getting into its final phases, you should be able to say yes or no, here is supporting evidence for everything, every task on there. Right? So design the watch face, bad example. I created a print for the watch face and it's attached here. That's a great example. Okay? So there's the difference. The other thing that I didn't talk about here is specifying resources. So for each of these tasks, you can specify a resource. And in these project management software, it will let you take a look at how you stack up. So if you have 2 things going on at the same time and you assign the same resource to both of those, it's going to know you need more time. Okay? Because you can't have one person doing 2 things in parallel right at the same time. Most of us do that all the time, but in theory, it's hard to do 2 things at the same time. So another thing to look at, if you specify resources in your project, make sure they're not overloaded. So let's talk about PIGS, man. So this is a very poor resolution, cute little pig. So PIGS are progress, issues, and goals. So most teams do these at the start of every lab meeting session, or at least most of my teams do. So progress, issues, and goals. I think they should be goals, progress, and issues, because they really go in that order. Okay. So if it's your first week, as a project or your first week doing PIGS, you should have stated goals, okay? Those goals should be, hitting the wrong keyboard. Goals should be actionable, so they should produce objective evidence. So if you have a goal for a week, it should never be something that is always true, okay? So if your goal is to build a museum exhibit, your goal should never be, or if your project is to work on a museum exhibit, your goal should never be, I'm going to work on the museum exhibit, or I'm going to design the museum exhibit. That's always true. You guys are always doing that. So it should be, I am creating a schematic for the handle of something that goes on the, right? It should be specific. And as your advisor or your TA or your team leader, your project manager, I should be able to say, okay, so you were this week going to create a schematic for this. Let me see your schematic. You should hold that up, okay? So if you're the project manager, you should be, before your lab session, asking your team for that objective evidence for their goals, okay? So every piece of the project should have a goal. You should be asking for that objective evidence and presenting it at the beginning of your meeting. So you can sit everybody down and say, okay, here were our goals from last week. This is our progress from this week. Here is the executed goal, okay? So a bad goal, again, I'm going to work on the design casing for the smartwatch. You're going to work on what? How do I know that you worked on it? You know, did you draw a doodle? What did you do? So a much better goal is I'm going to create a print for each component of the casing. So then you can come in and you can show me a set of prints and say, here are my prints. I did this work. It moved the project along. And so as a project manager, that lets you know that that work has been done and it's been done correctly. So progress for 1 week should be your goals from the last week, okay? So if this week my goal is to create the print for the watch casing, next week my progress should be I created the print for the watch casing. Now, if that doesn't happen, then we're going to go into issues. The other thing you need to look at as project manager is benchmarking your progress against your Gantt chart, okay? So you've created a Gantt chart, you're maintaining it every week because your project is going to slip, all projects slip. So you're going to create a project timeline at the beginning that's really ambitious, because we're all ambitious, we're great engineers, right? Or great whatever we are. And you're never going to hit your first timeline. It takes years and years of experience to realize that you'll never hit your timeline, not years of experience to hit a timeline, because no one hits timelines, okay? But we strive for that. That's why we set them, we try and be realistic. But when it slips, you're going to have issues, okay? The issues are the difference between your goals and your progress. So I had my goals, I subtracted out my progress, and it left me with my issues. Why didn't you achieve your goal? Okay. So as you, as a project manager, go in, you do your PIGS, you ask your design leads for their PIGS for each week, right? So your design leads should be feeding this into you if you're the project manager. And they're going to say, well, we were supposed to design the prints for the watch casing, but we got hung up because we weren't sure what material to use. We didn't know how wide it should be. Those are the issues that they should be giving you. And along with the issues, they should be telling you how they're going to resolve the issues, okay? So if the issue was, I didn't have enough time, how are you going to make more time in your schedule this week to get it done, to catch up? That's usually the most common but the worst issue. That should never be an excuse that you didn't have enough time. But if you have the issue of, I didn't know how to do this. I didn't know how to use SolidWorks, so I couldn't create the print. Then your issue should be, I didn't know how to use SolidWorks to create the print. I found the TA who does SolidWorks, and I asked them for help, and we're going to sit down for an hour this week and do this together. Or I went and found the lab manager, Andrew, who could help me with SolidWorks, okay? So you guys can always get me. I secretly know how to do everything. No. I don't, but I do know how to find people who do, okay? We have a lot of resources on this campus. We can find you someone who can do it. I know I'm about out of time. I do want to real quick do a PIGS activity. So take just a couple of minutes, that's about all we have, and create some PIGS for your project. So not for your whole team, but for the project that you work with the most, okay? And then we'll, maybe about 1 minute later, we'll trade and grade and try and look at how can you make your goals more objective, more measurable, okay? All right, if you haven't done so already, go ahead and trade. So again, look at each other's goals, look for how can you be more objective. Okay.
It's horrible.
All right, well, I think we're out of time. Did everybody get a good bit of feedback on their goals? Did that help at all? All right, great. Well, I'm sorry again about the technical difficulties getting started here, wasting a little bit of your